Go. Thank you, Imani. Okay. All right, we're starting a new chapter. We're going to talk about today operations on functions. Okay? Your operations being add, subtract, multiply, and divide. And we're going to talk about a different kind of operation called composition, but probably not today. Okay, so we need to talk about some notation first. Okay, a lot of times when you're going to add two functions together, okay, my little, there it goes. Okay, all right, when you're going to add two functions together, like f of x and g of x, it may be written like this right here, f plus g of x. Well, that just means this function plus this function. Okay, and then there's an example. Subtraction, same thing. It may say f minus g of x. Well, that means f of x minus g of x. Multiplication, it may say f times g of x. Well, that just means multiply the two functions together. And then division, f over g of x is f of x over g of x. But you have to make sure your denominator, you have to figure out what would make the denominator 0, because that can't be in your domain. Because remember, domain is part of your x values. So you can't have anything in your domain that would make the denominator 0. All right, we'll talk. It shows that over here. If f of x is 2x and g of x is negative x plus 5, then the division would just be 2x over negative x plus 5. But then you have to state that x cannot be 5.
I need a janitor to report to the homemaking room at this time. I need a janitor to report to Coach Murray's room, please.
Because if x were 5, that would be negative 5 plus 5, which would be 0. And denominator cannot be 0. If denominator is 0, that makes it undefined. So you have to state that in the domain, x cannot be 5. Okay? That's called a restriction on the domain. All right, so let's start. These first ones are probably going to seem really, really simple, hopefully. So let's start with example 1. I did give y'all a copy of the notes, didn't I? Okay. All right. Given f of x equals x squared minus 4 and g of x equals 2x plus 1, find each function. So what they want us to do, we're adding and subtracting, so what they want you to do, and you'll see that, is they'll want you to find f plus g of x and f minus g of x. So that's what we're going to do. We're going to find the sum and the difference. So f plus g of x just basically means f of x plus g of x. So that's what we're going to do. We're just going to add these two functions together. So f of x is x squared minus 4. G of x is 2x plus 1, and since we're adding, we don't have to put it in parentheses, just plus 2x plus 1. So basically, you're just writing them down just like they are and putting them together. So now you just combine like terms. So we have an x squared. We only have one x term, 2x. But then we can combine negative 4 and 1. What's negative 4 plus 1? Negative 3. And that's it. That's the answer. Not bad at all, is it? Now, subtraction can be a little bit trickier. So, f minus g of x just means f of x minus g of x. So, f of x, we're still using the same functions, x squared minus 4. But now we want to subtract all of g of x. So that means you want to do minus and you want to put g of x in parentheses, because you're going to need to distribute the negative. Okay, so we have x squared minus 4 minus 2x minus 1. Now we combine like terms. So we have an x squared minus 2x, and then we have a negative 4 and a negative 1. If you combine negative 4 and negative 1, what do you get? Negative 5. Negative 4 minus 1 is negative 5. So really, you're just combining like terms. But when you're subtracting, you got to be sure you distribute the negative to the function that you're subtracting. Alright, so now we're going to do the next one. Same thing. So this one is example 1A, if you want to put that on there. So this one will be example 2. Whoop, it's not right. It'll be example 1B, sorry. Alright, so same directions. These same directions. We want to add them and subtract them. So I'm going to go back to my red for adding, since that's what I started with. So we're going to do f of x plus g of x equals f of x is x squared plus 5x minus 2 plus g of x plus 3x minus 2. Then combine like terms, x squared. Okay, now this time we've got a 5x and a 3x. So it's 5x plus 3x. 8x. Then we got a negative 2 and another negative 2. Negative 2 minus 2. Alright. So now we're going to do f of x minus g of x. So we have x squared plus 5x minus 2 minus 3x minus 2. So again, we got to distribute that negative. So we have x squared plus 5x minus 2 minus 3x plus 2. It changes both of those signs. So when we combine, what do we get? Good. Well, it's negative 2 plus 2. They cancel out. Right, so that's it. Okay, any questions about adding and subtracting? Okay, alright, let's move on to multiplying and dividing then. So this is page 2, multiply and divide functions. Given f of x equals x squared plus 7x plus 12, and g of x equals 3x minus 4, find each function. Okay, so I'm going to use green. Okay, what they want you to do is find f times g of x and they want you to find f over g of x. Alright, so let's multiply first. So f times g of x, that just means take f of x and multiply g of x. So what we have then is f of x, and we're going to need to put these in parentheses. X squared plus 7x plus 12 times g of x, 3x minus 4. And you're going to do distributive property. We can't do FOIL because this is a trinomial. So we're going to have to take x squared and multiply it by both of these. 7x times both of these, 12 times both of these. Okay? Alright, so as long as you'll be, you got to be really careful. But as long as you're careful, you should be okay. X squared times 3x would be what? 3x cubed. We're doing distributive property. We're multiplying. So you're not combining like terms. You're going to multiply each term times each term. Okay? So x squared times 3x would be 3x cubed. X squared times negative 4 would be negative 4x squared. Okay? Now move to the middle term. This is the one I said I like to have the one with 2 terms in the front, but you don't have to. Alright, 7x times 3x is good. 7x times negative 4. X, good. Nope, we're moving to the 12. 12 times 3x. 12 times negative 4. Negative 48. Okay, now combine like terms. Well, we only have one x cubed term, so 3x cubed stays the same. Or it doesn't change. Alright, then we have a negative 4x squared and a positive 21x squared. What would that be? Plus 17x squared. Alright, then we have a negative 28x and a positive 36x. Good. Positive 8x and then negative 48. Okay? Now we're going to do f of x divided by g of x. That's what this means right here. F of x divided by g of x. So we have x squared plus 7x plus 12 over 3x minus 4. Now, I believe this top one is factorable. You could factor it into x plus 4x plus 3, but the denominator is not factorable, and it's not x plus 4x plus 3, so it's not going to do any good to factor the top. You can't simplify. Okay? So basically, you just leave it like that. But this down here cannot equal 0. So we've got to tell what can we not have in our domain. What can x not be? So what you want to do is go over to the side and say that 3x minus 4 cannot equal 0. And then solve it like you would an equation. Add 4 to both sides. So 3x cannot equal 4. Then divide both sides by 3. So x cannot equal 4/3. So that goes with the answer. You have to specify the restriction in the domain. So x can be anything, but it cannot, except 4/3. It can be anything else, but it cannot be 4/3. Okay, we're going to stop right there. And we'll come back to this tomorrow. Go over here.